This is lesson 3 of exponentiation, and we will be looking at multiplication of exponential numbers. In part A, we have 5 squared times 5 to the power of 4. Now, if we expand these exponential numbers, we will get 5 times 5 times 5 times 5 times 5. Now we get 5 6 times, and that is 5 to the power of 6. Now, if we use a different method, and since we look at the bases that they are the same, and we simply add the exponents, that is 5 to the power of 2 plus 4, we will get 5 to the power of 6. In part B, we have negative 3 cubed times negative 3 to the power of 4. Now let's expand them also. And we will come up with negative 3 7 times. And so this is negative 3 to the power of 7. Now, like how we saw in part A, since the bases are the same, we can simply add the exponents. That is negative 3 to the power of 3 plus 4, such that we get negative 3 to the power of 7. In part C, we have a to the power of 5 times a cubed, where a is a non-zero rational number. Now, let's expand a to the power of 5 and a to the power of 3 to come up with a 8 times. So this will give us a to the power of 8. Now, since the bases are the same, we can also add the exponents. That is a to the power of 5 plus 3, such that we get a to the power of 8. Now, if a is a non-zero rational number, m and n are positive integers, we will follow this to come up with the law 1 of exponents. That is a to the power of m times a to the power of n equals a to the power of m plus n. But we only add the exponents if the bases are the same. In case the bases are not the same, we cannot add the exponents. Now, let's simplify the following and we'll leave the answer in exponential form. Number 1, we have 3 to the power of 4 times 3 to the power of 5. Number 2, we have negative 5 cubed times negative 5 to the power of 6. Number 3, we have 4 out of 5 squared times 4 out of 5 to the power of 9. Number 4, we have 7b to the power of 4 c cubed times 2b squared c. And number 5, we will have 5xy cubed times 4x cubed y squared. In number 1, we have 3 to the power of 4 times 3 to the power of 5. We have got 3 to the power of 4 times 3 to the power of 5. Now, like how we have seen already, we need to check if the bases are the same. For this case, we have base as 3, and here we have base as 3. Now, since the bases are the same, we will keep the base, that is 3, and add the exponents, that is 4 plus 5. Okay, so if we get 3 as the base, then 4 plus 5, we come up with 9. So therefore 3 to the power of 4 times 3 to the power of 5 equals 3 to the power of 9. In number 2, we have negative 5 cubed times negative 5 to the power of 6. So also, if we have negative 5 cubed times negative 5 to the power of 6, and since we can see that the bases are the same, it means that we will keep the base and add the exponents, that is 3 plus 6, such that we get negative 5 to the power of 9. Okay? In part 3, we have got a fraction, that is 4 out of 5 squared times 4 out of 5 to the power of 9. So since the bases are the same, that is 4 out of 5 and 4 out of 5. So we will keep the base, which is 4 out of 5, and add the exponents, that is 2 plus 9, such that we get 4 out of 5 to the power of 11. And that becomes our final answer. Number 4, we have 7 b to the power of 4 c cubed times 2b squared c. So this, we will first of all get 7 times 2, then we get b to the power of 4, then b squared, then c cubed, and c. And in this case, c is to the power of 1. So we will get 7 times 2, it is 14. Then since this base is the same as this base, we will get b to the power of 4 plus 2. Then since c and this is c, we will get c cubed plus 1. And we get 14 b to the power of 6 c to the power of 4. And this becomes our final answer. In number 5, we have 5x, y cubed times 4x cubed y squared. So let's first get 5 times 4 x and x cubed, y cubed, and y squared. So 5 times 4 we get 20, and since this is x and this is x, we'll get x to the power of 1 plus 3, then y cubed plus 2. And we come up with 20 x to the power of 4 y to the power of 5. And this becomes our final answer.